myself Vijay, working as the assistant professor, belongs to the department of EEE. Today's lecture is going to see Vlsi Design under the topic NMOS, PMOS and CMOS basics. So what is MOS? MOS is nothing but metal oxide semiconductor. Why we name it as the NMOS and why we named as the PMOS? So NMOS, the majority charge carrier electrons and the minority charge carrier as holes. While in the type of PMOS, the majority charge carrier are holes and the minority charge carriers are electrons. But both the weight for the MOS is common for NMOS and PMOS. Why we name it as the MOS? The metal portion is indicates the gate, drain and the source. These three are made up of the metal region and another one is the oxide. So where the oxide is occur, the gate is made up of silicon region. So this we call it as the SiO2. So we represent the oxide layer. So these substrates are made up of purely semiconductor material. So that's why we call it as the metal oxide semiconductor region. So now we are going to see about the electrical properties. So this is the NMOS diagram. So a gate is here and source and drain. So drain is connected to the supply line. Normally we call it as the VDD, and source is connected to the ground terminal. So when we are giving signal to the gate, that means when gate G equal to 1, the transistor response is on. When gate G equal to 0, the transistor response is off. So what it indicates, when we are giving signal to the gate terminal, so the current is moving from drain to source. So that means the transistor is in the on condition. Similarly, when you are removing the signal from the gate, that is gate equal to 0, the transistor is off position. There is the no conduction between the drain and the source part. Similarly for the PMOS. So draw the PMOS diagram. So this is drain, so this is source, again gate. So drain is normally connected to VDD and the source is normally connected to the ground. Again we are giving signal when G equal to 1, the transistor response is off. When gate G equal to 0, here the transistor response is on. So this is the main basic difference between the electrical properties of the NMOS and PMOS. Looking at the diagram, here when gate equal to 1, the response is on, but in the PMOS, when the gate equal to 0, the response is on. Remaining both the conditions for the NMOS and PMOS, the transistor response is off. So again the similarities between the NMOS and PMOS, here there is the no bubble. This bubble indicates the PMOS structure. So here there is the no bubble. For NMOS we are not representing any bubble like structure, but in the case of the PMOS, we representing the bubbles, it indicates the PMOS. So what is the NMOS and PMOS? Already I said the NMOS, the electrons are the majority carrier and holes are the minority carrier. For the PMOS, electrons are the minority carrier and holes are the majority carriers. So this is the beautiful properties of the NMOS and PMOS. Now we are going to see about the CMOS. So CMOS. So CMOS is nothing but the complementary metal oxide semiconductor. So what is CMOS? The combination of both. So CMOS is nothing but combination of both NMOS as well as PMOS. So the structure of CMOS, so normally we draw the VDD line, then NMOS, then one PMOS, and then ground. So the PMOS are placed in the upper part of the region, NMOS are placed in the lower part of the region, and the output we are taken here. So this is call it as the output. We represent as Y. So these both the case are input. So A is the input and Y is the output, and this is the PMOS. So and this is the NMOS. So this is the structure of the complementary CMOS category. Why we call it as the complementary CMOS category? We are well known. So it working as an inverter. So what is the inverter? This is A. Consider this inverter. This is A. Input, Y output. Suppose we are giving input A equal to 1, we getting the response Y equal to 0. Suppose we are giving A equal to 0, the response Y equal to 1. That's why we call it as the inverter. So the CMOS act as the inverter, that will be see the later. Now we just apply the input what to be happened in this structure. So consider that when you are giving the supply A equal to 0. A equal to 0, we already discussed that the PMOS having the electrical property, if the 0 is moving here, the PMOS response is on. Similarly, the same 0 is moving in the NMOS, the NMOS response is off. Correct? So what will happen? Once we receive the input 0 from A to PMOS, it automatically on, it pulls the supply from the VDD and gives the output. Then Y having the output. So it becomes the on. Or it receiving the signal from the VDD. So VDD nothing but the supply, right? It pushes it receiving the signal from the VDD and gives the output Y equal to on. Suppose we are applying 1 to this input. So the 1 is moving to the PMOS device. At the same time, again the same one is moving to the NMOS device. So what will be the response of the PMOS? For 1 it will be off. For 1 it will be on. So in this time, so it receives the output from the Y to ground. So here is the gate, drain, source, drain. So by this way it will be working. So when we are giving input 1, so when we are giving input A equal to 1, it receives the supply VDD and given to the output Y. When A equal to 0, what will be happen? Y to ground. Now we are going to see the implementation of CMOS using NAND gate structure. So this is called the VDD line. So CMOS NAND gate implementation. So this is the ground. So A, so this is called B, again A, B. For NAND gate implementation, the NMOS is in the combination of parallel structure, the PMOS in the combination of parallel structure, NMOS in the combination of series structure. So the NMOS is series and PMOS is parallel. So we taken the output as here. We know the truth table of the NAND gate. Truth table NAND. So A, B considered as the input, Y as our output. So 0, 0, 0, 1, 1, 0, 1, 1. So the NAND gate, the output is 1, 1, 0. So now we apply this input to the structure. So when consider A equal to 0, B equal to 0 for the first case, then A equal to 0, B equal to 0, again A equal to 0, B equal to 0. So what is the response of the PMOS? A is equal to 0, it becomes on. It also on. When NMOS, we are giving 0 to the NMOS, it becomes off. So it becomes off. So there is the possibilities to receive the supply VDD and gives the output. So our output is 1, it becomes okay. So now we apply the second input. Now the second input we are going to check. Though is A equal to 0, here A equal to 0, here A equal to 0. So B equal to 1, B equal to 1, B equal to 1. So now the response A equal to 0 for this PMOS on, for this PMOS off. So for in this case off, and this will be the on. So the PMOS has the combination of the parallel structure. So these PMOS, it should be activated. It receives the supply from VDD and it gives the output Y equal to 1. So these conditions also correct. Then next apply the third input. So third input A equal to 1 and then B equal to 0, when A equal to 1, here B equal to 0, then A equal to 1, B equal to 0. So see the response. So A equal to 1, it becomes off. When B equal to 0, it becomes on. When A equal to 1, it response is on. When B equal to 0, it response is off. So what do we happen? So obviously this VDD gives the supply to the Y becomes 1. So we get these PMOS will be activated, these become deactivated. It receives the signal from VDD and it gives to the 1. So obviously we get the output as 1. Now check out the last input A equal to 1 and B equal to 1. When we are applying A equal to 1, here B equal to 1, here A equal to 1 and B equal to 1. We know the properties of PMOS. When we are giving A to 1, it becomes off. It becomes off. So it becomes on, it becomes on. So there is the no possibilities from VDD to output. And automatically both A equal to 1, B equal to 1, these should be on, these should be on. So automatically the output is going to the ground. So Y equal to 0. So this is the NAND gate output. So this is the implementation of CMOS transistor by the NAND gate. So similarly we can doing the NOR gate also possible. So now we are next going to see about the NOR gate implementation. So in NOR gate implementation, the PMOS is in the NMOS is parallel and PMOS is series. So draw a diagram. So this is the VDD line. So this is PMOS. So these two become NMOS. A, B, as usual we take an output is here. So NAND gate, NOR, the answer becomes 1, 0, 0, 0. Now we check out the input and how is the response of the gate structure. Then A equal to 0 and B equal to 0 is the first input. Consider A equal to 0, B equal to 0. So this will be the on state. This should be the on state. So A equal to 0. This should be off and B also off. So both the gates should be on. So we know the VDD supply is gives to the result. So it receives the signal from VDD to Y. So the response is Y equal to 1. It becomes correct. So next we are applying the second. So the second input consider 0 and 1. So 0, A equal to 0, here A equal to 0, then B equal to 1, here B equal to 1. So A is equal to 0, D should be on, D should be, B equal to 1, D should be off. When A equal to 0, D should be on, D should be, so A equal to 0, D should be off. and this should be on. So now the only the A transistor alone becomes on. So the B, the next CMOS is off. So we cannot get this output VDD from Y because of the out. So normally this should be on. We cannot receive any output from the Y terminal. So it becomes 0. So this is also similarity same when A equal to 1, B equal to 0. We need not worry about the NMOS. So again, what to be happen here? Off and here on. So check out the input 1 0 1 0. This should be on, this should be off. There is no possibilities to receive the output VDD from the Y. So here also the 0. Then obviously find the last one. When A equal to 1, B equal to 1, A1, B1, both should be the off, both should be the on. So now what will be happen? So these should both the NMOS transistor will be on. So Y already we are having the output, so these will be pulled down to the ground. So we getting the 0. Normally PMOS we call it as the pull up device. So PMOS we call it as the pull up network or device, and the NMOS we call it as the pull down network or device. So I hope you are all like this video. So now the things we are discussing is the NMOS, so PMOS and CMOS. So NMOS we seen about what are the basics of the properties and electrical properties. Similarly the PMOS, the electrical properties, and the NMOS we have to see the structure, and NMOS NAND gate implementation and NOR gate implementation. Thank you.